Welcome to the Deep Dive. We're here to unpack some really intriguing corners of knowledge, just for you. And today, we're diving into something that feels almost impossible, a mystery. It's colossal, it's geometrically perfect, and honestly, based on everything we think we know about nature, it probably shouldn't exist. And it's way out there, far from Earth. We're heading to Saturn, the jewel of the solar system. But this deep dive isn't really about the famous rings today, no. It's about something much, much stranger, hiding right up at its North Pole. So our mission is to unpack this extraordinary phenomenon. It challenges some pretty basic ideas about how natural things form, and some of the details are, frankly, kind of mind-boggling. Okay, so picture this. Imagine you and I were hovering right over Saturn's North Pole, looking down through those pale, sort of yellowish swirling clouds. Now, even if you know a bit about planets, what's going on there, it defied easy explanation.
It really does. You'd expect chaos, right? Swirling clouds, storms maybe, but random. Not something with this kind of, profound organization. The whole idea of something so geometric, it just immediately makes you ask, what on Saturn could possibly be doing that?
Exactly. And what you'd actually see is this colossal structure, a storm system, but it's in the shape of a near-perfect hexagon.
A hexagon, yeah.
6 incredibly straight sides, distinct corners. It's bizarre.
And that is precisely what makes it so deeply mysterious. I mean, think about storms here or anywhere else we look. They're spirals or just messy circles, always.
Hurricanes, cyclones.
Exactly. So this thing, it just completely breaks the mold. Its existence makes you, rethink how planetary weather works, doesn't it? The whole chaotic nature assumption.
And just to clarify for everyone listening, it's not quite like one single storm, like a hurricane on Earth, is it? It's more fundamental than that.
That's right. It's actually a jet stream, fast-flowing current of air, or gas in this case, moving incredibly fast over 200 miles per hour. And somehow, this jet stream has bent itself into this perfect six-sided shape.
And you said colossal. We need to understand the scale here.
Oh, the scale is staggering.
Yeah.
Get this. Each one of those 6 straight sides, it's longer than the entire diameter of our planet Earth.
Longer than Earth's diameter, each side.
Yeah, just let that sink in. This single feature could basically swallow Earth whole 6 times over, side by side.
That's almost impossible to visualize.
It really is. But it's not just the size that's astounding, it's how incredibly stable it is, how long it's lasted.
Okay, how long are we talking?
Well, the Voyager spacecraft first got a glimpse back in the 1980s.
The 80s, okay.
Then, the Cassini mission, which orbited Saturn for years, watched it in amazing detail for over a decade, from 2004 to 2017.
So we have really good data on it then.
Absolutely. And through all that time, it was just there, rock solid. So it's been stable for at least 40 years that we've seen. But scientists think it's likely been there for centuries.
Centuries. Unlike, say, Jupiter's Great Red Spot, which we know is shrinking.
Exactly. The red spot is dynamic. It's changing. This hexagon, it just seems to sit there, unwavering, quietly spinning at Saturn's pole.
Which brings us to the big question, doesn't it? The why. Why a hexagon? Why 6 sides? Why not 5 or 8? Or, just a normal circle like every other storm. There's really nothing like it here on Earth, is there?
Not even close. And that's the puzzle planetary scientists are really digging into. But the leading theory, it involves something quite elegant, actually. Standing waves.
Standing waves. Okay, that sounds a bit physicsy. Can you break that down for us? How does that relate to Saturn?
Sure. Think about plucking a guitar string.
Okay.
The wave travels along the string, right? But it reflects back and interferes with itself. And it creates these points that seem to stand still nodes while the rest vibrates. That's what makes a clear, stable musical note.
Right, I can picture that. The string vibrates in segments.
Exactly. So the theory for Saturn is that something similar is happening, but in the atmosphere, on a planetary scale. Because of Saturn's fast rotation and the specific properties of its deep atmosphere, disturbances like smaller storms or variations in the flow can get sort of organized. They can settle into a stable standing wave pattern that wraps around the pole.
And that pattern happens to have 6 points.
Precisely. A standing wave with 6 peaks and 6 valleys. And that pattern shapes the jet stream into the hexagon that we actually see.
So the hexagon isn't the wave itself, but the jet stream following the pattern of the wave.
You've got it. The wave pattern acts like a boundary or a guide for the fast-moving jet stream.
That's beautiful, in a way. It's like a musical note being played by an entire planet's atmosphere.
That's a wonderful analogy. A planetary symphony held stable for decades, maybe centuries.
It really reframes how you think about weather, doesn't it? Not just chaos, but potential for deep order.
It certainly does. But if that wasn't enough mystery for you.
Oh, there's more. Go on.
Well, the hexagon, it changes color.
It changes color.
How? With the seasons on Saturn. Remember, a Saturn year is almost 30 Earth years long, so seasons are very slow.
Okay.
When the Cassini spacecraft first arrived, the hexagon looked quite bluish.
Bluish. Right.
But then, over the next few years, as summer slowly arrived in Saturn's northern hemisphere, the hexagon gradually turned golden, yellowish gold.
Whoa. From
Yeah.
blue to gold. Why would seasons change its color?
Well, the thinking is it's all about sunlight. As the North Pole tilted more towards the sun during summer, the increased sunlight triggered photochemical reactions in the upper atmosphere inside the hexagon.
Photochemical, like smog formation here on Earth.
Kind of, yeah. Sunlight breaking down molecules and allowing them to recombine into new things. In this case, it created tiny particles, sort of haze, a photochemical haze.
And that haze changed how the light reflected, making it look golden instead of blue.
Exactly. We're literally watching seasonal chemistry unfold inside one of the strangest structures in the solar system.
That's incredible. So let's just recap this whole thing. We have this giant, geometrically perfect hexagon storm. It's bigger than Earth many times over. It's been stable for at least decades, maybe centuries. And it changes color with Saturn's long seasons because of sunlight, triggering chemical hazes.
That's the essence of it. A geometrically perfect storm, stable for ages, that has seasonal weather inside it. It's quite a package.
It really is. It just blows my mind that something like this can form naturally.
It challenges our intuitions, definitely.
Okay.
It shows how the basic laws of physics, fluid dynamics, wave mechanics can conspire under the right conditions to create incredible, unexpected order.
It's like natural art on a planetary scale.
A perfect description. A reminder that the universe isn't just random chaos. Sometimes you get these pockets of perfect geometry emerging purely from physics.
It's a profound thought. It makes you wonder what other kinds of hidden order might be out there.
Absolutely. And it highlights how much we still have to learn even about our own solar system neighbors.
Well, thank you for walking us through this truly bizarre and fascinating piece of the cosmos. It's been quite the deep dive.
My pleasure. It's an amazing phenomenon to talk about.
So, until next time, keep looking up, keep wondering, and maybe, just maybe, dream of the perfect patterns hidden out there in the cosmos.